In this video we are going to learn how to start and stop these motors so the vehicle moves. We are going to learn how to change the direction so we can go forward and backwards. We're going to learn how to control the speed of the motor so we can speed it up and slow it down. Then we are going to learn how to turn left and right by controlling the front servo for the steering. How we can run a program when our robot starts, the program runs. Hi, welcome to a product tutorial by Robojax. This is SunFounder's PiCar-X Raspberry Pi self-driving robot car kit.
Hello friend, how are you? Turn left here. Count down to 3 seconds. 3, 2, 1, run. I lost.
I'm now on the documentation page for this robot on SunFounders. Under the play with Python, let PiCar-X move. So this is a code. First we are going to run this code, changing the directory to this alias of the directory PiCar-X /example, and then we are going to run this move.py using the sudo python3 command. On the start menu, type power and you will see PowerShell and run it as administrator. Then we will type ping -4. That means we want the IP version 4 response, and this is a host that we set at the beginning of the setting up the Raspberry Pi, which I explained it. .local is already included, so I press enter, and as you can see our robot is responding. The IP is 192.168.0.102, so that's a good sign. I'm typing clear. Now let's connect via SSH pi at robojax.local, and I'm entering the password and I got connected. So now I've got connected to the Raspberry Pi. Now we could copy and paste it in here or type it from here. So another way is to use the create agent from SunFounder. Just type sun at the start menu and you will see SunFounder, run it. Now it's running at the background. If I click here, you will see SunFounder is running in here. Now I'm clicking here to connect, typing the IP address, the username which is pi, and the password. So successfully connected. Now we can run this code. So I press Ctrl-. So this is the screen, and let's run this code and see if the motor moves. This is the code where the motor moves, the steering turns left and right, and then the servo cameras, the camera servos will move also the camera. I'm clicking on run. So let's run it again. Now I'm clicking on run. So this moved, that servo moved, and also the camera moved. So this was controlling it via this command line. And so this is the code that we just saw in action. Let's see the code in the bigger screen. The location of the code is in here. So let's go. CD, just type PiCar and I'm pressing tab, example, and here nano move.py. So that's an application to open the text and read it. The cursor is at the top, that square is the cursor, so I have to use the arrow to come down if I want. So at the top we are importing from PiCar-X module the class called PiCar-X, and we are importing time because we are using it for sleep here to wait, and this portion is including the original included file. It checks it, and then try means execute this, and we are creating from this PiCar-X class, we are creating an object called px, and we are using it in short form. This line is sending the motor forward in forward direction with 30% of the power, so we are using px PiCar-X dot forward, and then for 0.5 seconds. So this will run for this much time, because as soon as this is executed for this much time, and immediately we have one for loop. This is a for loop, and this is another for loop, and this is another for loop before we go to stop. This for loop goes from 0 to 35, and the value of 0, 1, 2, 3 up to 35 is stored in a variable called angle, and this angle is coming to this line. We get PiCar-X and set direction servo angle. This is the angle for the steering, and we are passing that angle in here. So when this becomes 0, we are sending 0, the steering goes to 0, then goes to 1, 2, 3, 4, up to 35. But between each iteration, when this line is executed, it gives it 10 millisecond, 0.01 second, and it comes and increments it to the next value, and then 1, 2, 3, up to 35. When it reaches 35, this is 0, 35 is in here. Then it goes to the next loop. This loop starts from 35 up to minus 35. Minus 1. In order to go in the negative direction, decrement, we have to define it in here as minus 1. Here we haven't defined it because it is positive, very simple increment, but this one we did. So this goes from 35 to minus 35, which means it goes from 35 it comes to 0 and minus 35. So 70 degrees movement. The same way with 0.01 second delay, and then from minus 35 it goes back to 0 using the same method. So from here it goes back to 0, so from here it goes back up to here, so it's straight. Now I'm going down with this arrow key. I'm bringing the cursor, this is the cursor, I'm bringing it down. So this was the last line. After that we wait for 1 second. This 1 means 1 full second, and then we have 6 for loops. This is sending from 0 to 35. This is a new function, a new method called set cam pan angle. Now when we move the camera to left and right, that's called pan, and when the camera is heading down or up, that's called tilting. So it tilts up and down and pan left and right. And the same way we have 0 for the tilt, and then 35 up, 35 down, and for the pan 0, 35 to the right, 35 to the left, minus 35. So when it goes to the left, minus 35. The same way for the tilt, 35, 0, minus 35. So this is for the pan. We go from 0 to 35, and then from 35 to minus 35, this portion, and then from minus 35 back to 0. So the values are clearly speaking. After that, we have 3 more for the tilt. 1, 2, 3, and you see there is 3. For the tilt, the same way, 0 to 35, this is called tilt angle, and here you can see it says pan angle. And then from 35 to minus 35, and from minus 35 to 0, and between each iteration we have 0.01 second time, because if you don't give it time, it might not be able to move it because it goes immediately to the next iteration. So you have to give time for the servo to move. And then we go PiCar-X.stop. So this method is stopping the vehicle. The rest of the code by selecting it. This is a very good and easy way to learn. So this is our code. It sends the car forward with 30%, and let's change this to 5 seconds. And after that, let's stop it. Stop is the same, PiCar. Make sure to respect this indent. Each indent has effect, so if this starts from here, the rest should be with the same indent. So PiCar-X.stop, and let's run the code. So this will run for 5 seconds, and it will stop. If you want to go in reverse direction after stop, let's go PiCar backward, and let's go 60%, this time faster, and then time dot sleep for 4 seconds, and then PiCar dot stop. So let me separate them. So this is sending for 5 seconds at 30% and stop, and then this portion backwards for 4 seconds and stop. Let's run the code. So 5 seconds forward. Okay, so now it's faster. You saw that there was a glitch because this is not the right way to just go from forward to backwards, so we have to add here a delay. Time dot sleep, like 1 second perhaps, or maybe 2 seconds. Give it time so it stops. Now let's run. Going forward, now stop, 2 seconds, and then goes backward. So this way you can control the car whichever direction you want. Now let's see, I just pressed reset to bring the code back. Now let's see how we can control the speed of the car with any value that we want with this loop with different values. So in here I'm going to delete the rest of the codes, and instead of angle I'm going to call it speed, and from 0 to 100 because that's a percent, and in here I'm going to say servo forward. We can do forward or backwards, and then we pass the speed, this variable in here, and give it 0.1 1/10 of the second. So what does this mean is that this value goes from 0 to 100 and assigns to the speed. So speed is 0, 1, 2, 3 up to 100, and every time it changes we send that value to the motor. So when it is 0, so this is 0, and it sends 1, 2, 3, and it changes. Instead of sending it like that, let's remove that, and let's run this code now. So now pay attention here. Let's run it. I made mistake here. There is an E. Delete. And then run. So it went to the maximum speed and stopped. If we want to go backwards, let's copy it, and in here let's have some sleep time or wait time. Let's say 3 seconds maximum. So after that, let's stop it and then wait for 2 seconds time. So let's clarify this. We go from 0 to 100% speed for 3 seconds. So when it reaches 100%, then we wait for 3 seconds. It goes at 100% speed, and then we stop after that for 2 seconds. Now below this, I'm going to paste the same code, the same loop. This time I'm going to say backward. And it goes, after stop, it goes backward, and here we have to make sure to go from 100 to 0 and the increment of, let's go -5. You can do -1, but I'm going to do it faster. -5, and here also I want to go with the speed increment of 5. So this 5 means go from 0 to 100 with the increment of 5. So it starts with 0 and then 5, 10, 15, 20, 25, 30 and so forth, and from here it starts from 100 and then 95, 90, 85, 80, and it goes down with the increment of -5 until it reaches 0, and we exit. So let's run it. It goes slowly with the increment of 5. And stop now. It should go back. Okay, I made mistake here. I typed PiX. It was just PiX. You see it gives error here. So I fixed it, and now let's run it forward again. Now it didn't have enough time, so we have to go maybe 100% and then go down, or let's not stop it. So we go for 3 seconds, and then after that we slow down. That would be better. Let's run it. Not good. Again, there was a problem, because when you change the direction from 100%, go back to the 100% of the other direction, that is not nice. So we have to stop. And let's go in the opposite direction from 0 to 100 and the increment of 5. So this was forward and this is now backwards. Let's run it. So this is speeding up. And you saw this was stopped immediately because we did not have a sleep time here, a wait time, so we could add it. So this was how you can So this was how you could control the speed of the motors. So we learned how to control the start, stop. We learned start and stop, forward and backwards, and speed control for the vehicle. Now, in order to control each motor, we will import from Robojax this class called motors, and we include also time for sleep and delay. Then we create from this class, we create an object called motors with lowercase, and in order to identify left and right motor, we are using 1 and 2, and I'm using this variable so we don't have to worry about the number. Now to control the motor, we use this object, and then we motors left, and then dot speed, and then minus 50, and then for the right we use 50. Now these two motors will rotate. So if this motors, in order to go forward, should rotate clockwise, you see this. So the left also should run in the other direction, so this will be counterclockwise. So these two will rotate always opposite of each other to go in the same direction we want. So we run these two, the car will go forward for 3 seconds here, time.sleep, and then motors.stop, this object, the same object, .stop will stop it, and we have applied 2 seconds, and then we go for reverse. Now the left was with minus 50, and this is now 50, and the right was with 50, now it's minus 50. So this minus will change the direction, and this number is 50% of power, so you can go from 0 to 100. Now let's run this on the table. Now I've typed sudo python 3, which is inside Robojax. This is the code that I've written. I'm running it, so I am running and entering the code. So this goes forward, you see both of them. Now this goes reverse, and this one goes also the same way. Both of these are going. Now let's see how we can control the steering. I'm pressing reset, so the code is coming back, so you are not worried. Now if you want to just control the steering, let's learn which portion is controlling. So I'm removing this forward, and this portion is for steering. Let's remove the rest. So this portion is just for steering, and we can send it to any angle, let's say 35, and then 0.1 second time if some action is happening afterwards. As simple as that. So this will send the servo to 35 degrees, and let's wait 3 seconds, and then PiCar-X.set servo angle minus 20. Let's say give it time for 3 seconds or whatever. Now I'm running this, so you can see this goes 35 degrees to the right and 20 degrees back to the left. From here it goes directly there. Let's run. So we have to have the indent, the PiCar, fix the indent. Otherwise it will not run. Now I have fixed the indent. This was back, so I moved it. It's on the same line. Now let's run. So 35, and then it goes directly back to 20. So that's 20 degrees. So this way you can send the steering or turn left or right at any angle you want. Now let's see how we can run a program. When our robot starts, the program runs. I type dir and we want to run this move program when the robot starts. To do that, we will go to the scheduler or cron job, sudo cron tab -e. So this is running as super user, as a root user, and then running the cron tab, that's the scheduler, and -e means edit. This is our file where you can write. The cursor is in here. I'm using the arrow to come down. You see it's here now. And in here we are going to write at reboot, and using Python we are running move.py, which is located inside example, PiCar-X, Py, and home. So you have to write the full path. After writing it, press Ctrl O to write out, Ctrl O, and then enter to accept it, and exit, Ctrl X. I'm using Ctrl X. To know the current working directory, type print working directory pwd, and you see this is the path. That's why this file is located after this. So that was a full path. Now I'm gonna reboot the robot. Sudo reboot now, and I'm pressing enter. As you can see, the light is blinking. So this is rebooting, and the same action that move this steering and the pan camera, pan and tilt. Let's see. So this way you can run your program and put it on the floor and test it. Here the robot is off. Let me turn it on, and the move will run. The move.py will run. Let's see what it does. So that was a task that it did. Now I got disconnected. To remove the code, let's ssh py at robojax.local. Our robot needs time to reboot, and then let's type sudo cron tab -e. And scroll down with the arrow, and here just add comment. So this is now part of the comment. These are all comments. They don't do anything. Ctrl O and Ctrl X. Ctrl O, enter, Ctrl X. And now if the robot reboot, script will not run.